Right, folks. Good evening. Welcome to the AWS Developer Certification Program. My name is Savitra. I'll be your instructor. Okay, folks. Let's get started. So, welcome once again. As you know, this is a certification course for AWS developers. Let's take a moment to see how this Edureka course works. First, let me tell you about my AWS experience. Overall, I have about 16 years of technology experience. I've worked in companies such as TCS and Citibank. I've been using AWS for 6 years. And for instance, I had set up a SaaS business, a software as a service business. And in that role, I was involved on the sales side. Essentially evangelizing cloud and SaaS to an audience that was not very familiar with cloud computing. But also on the technical side, I was involved in the design, building, as well as maintenance of the AWS infrastructure. And this was over a period of five years. In a subsequent role, I also managed the profit and loss of a large technology product. And in this role, I was involved with the cost optimization of the AWS infrastructure. All right, so that's a little bit about my AWS experience. Also, as you know, this is a live online class, and the key feature, I think, is the in-class questions. Right, so please use the questions section of your webinar panel to communicate with me. I would much rather spend time on questions and keep the lecture side of things to the minimum because I think the questions reflect your learning needs, right? Please also note that all the sessions here are recorded and they are available in the LMS, the learning management system. You should have received the credentials to the LMS in one of the emails from Edureka, right? And please note there are module-wise assessments or quizzes, and there are also assignments for each module, right? And please note that AWS and developing with AWS is a skill, right? So it's not enough to know things; you have to sort of practice this. So the assessments and project work and assignments are very important for you in this course. And of course, there's at the end of the course, there's a verifiable certificate that will be issued to you. Let me take a moment to show you the LMS as well. If you log into the LMS, you should see something like this. This is the course right in the middle. And if you were to click on that course, you should see panels such as this. For instance, this panel shows you the recorded sessions, and the third panel is the course content, right? So, for instance, today's presentation is available at this link, and then you can see the other sections here, which is the assessments and assignments. All right. Please also note that if you have any difficulty, if you need support, you can use this support button right here. And if you have any questions after the class, please use this discussion forum. All right. Please also note that this is how you join a class. Right now, you're already in the webinar, but for the next time, if you go into the LMS, click on your course, and in the course dashboard, you should see the Join Class button in green. And you can see in my LMS portal, this is the button here on the right side. All right. Now let's take a look at the course as a whole. This being the first session we have together, let's sort of go through what this course will involve for you guys. So as you know, this is a 12-module course. Each module is conducted over 3 hours on a single day. And given this is a weekend batch, we will be able to cover this course over 6 weeks, right? Module 1, which is today, is essentially cloud essentials, definitions, basic concepts, a little bit about AWS. We'll also look at the market side, the cloud industry, where AWS fits in. We look at things like use cases of AWS. We look at the major customers of AWS, right? So it's essentially concepts and the business and market side of AWS today. The next module, which is tomorrow, we will look at the fundamentals of AWS, what it is, what it is not, how to access, how to manage AWS infrastructure, and we will look at the key offerings in categories such as computing, storage, networking, big data, right? So we'll look at all the various services that AWS offers. Modules 3 and 4 is when we will do hands-on exercises, right? And we will use the AWS console, which is essentially a way to manage your infrastructure using the browser. And in module 4, we'll use a Java software development kit and also a command line toolkit, right? So this the SDK and the command line tool can be used to sort of programmatically control your infrastructure, and the AWS console is essentially a web console, so you can manually manage the infrastructure, right? And in these two modules, 3 and 4, which is next week, we will do hands-on exercises on the key AWS services, such as EC2, Elastic Cloud Compute. We will look at storage, for example, S3, which is Simple Storage Service, and other major offerings. All right. Modules 5 through 9 are important, especially for production environments, right? So if you're looking to deploy in production, you have a serious application, serious use for the cloud computing infrastructure. Then things such as monitoring and metrics, right? So you need to know, for example, if you're running out of storage, right? So you need to monitor that. You need to get notified, and then perhaps you need to take some action, like expanding your storage, right? So we'll see that in module 5. Module 6 is about high availability. So things like load balancers, automatic scaling of your application servers or web servers, database replication, right? So these are the things we'll cover in module 6. Module 7 is data management, especially we look at storage options and things such as backup of your application data, database backups. We'll also look at disaster recovery related services. Module 8 is security and networking. So here we'll look at access control, right? How do you control access to your infrastructure? Who can do what, and what are the things they can do and they cannot do? And also security from a networking point of view. So network, access control lists, virtual private cloud, those sorts of things. Right, and module 9 is going to be deployment and provisioning. Here we are going to look at how AWS makes it easy for you to deploy your applications, especially for a production environment, but also if you want to replicate your environments, your production environment into test environments as well, right? And things such as continuous integration, continuous delivery, where essentially in an automated fashion you can build, test, and deploy your applications. Right, so this is module 9. Module 10 is a special case. This is analytics and big data, and as we'll discuss later, big data and analytics and cloud computing are made for each other, especially because you need a large number of servers, a lot of infrastructure for big data. and you need them usually on a temporary basis, right? So this sort of thing is very hard to do in a traditional data center. So this is a special case that we will cover. And module 11, we'll look at best practices. And this should shorten your learning curve, right? So you must look at security best practices, right, or best practices around database replication or database backups. And this will save you time because in a production environment, it is best that you deploy using the best practices that are already well known. And the final module is cost optimization. This is something that I have seen in my experience. Developers tend to focus on their application. They tend to focus on, for example, user experience, speed, and things like that, but they tend to neglect the cost side. And businesses often get surprised by the bills, the monthly bills that they get. So there are several options in AWS, such as reserved instances, and developers must be aware of these and should sort of incorporate these strategies early on, right? So that's going to be the last module. All right. So all in all, I would say this is a very comprehensive course. It covers concepts, the business side of things. It covers hands-on exercises, especially on the major service offerings from AWS, right? And at the end of this, including these live sessions and the hands-on assignments that you will do, you should be in a good position to use AWS, especially in a development and test environment. And depending on the practice that you put in, the hours that you put in, also in a production environment. Okay, so guys, let me stop here for a moment. Please let me know if you have any questions on the course, the LMS, or anything else. So I think, Bhaskar, I can see your question. Are we going to explore CloudFormation templates in Module 9? Yeah, certainly we can do that. That is one of the services, as you seem to know, that eases the deployment and provisioning. So we'll certainly look at CloudFormation. Any other questions on the course content? Okay, Sasanka, yes. After the course, you will be able to. Okay, so which certification are you referring to? Because there is a certification that Edureka offers, right? At the completion of this course, if you complete the assessments and the assignments, there is a Edureka certification that is certainly available. Or if you're referring to the AWS certification, that's a different matter, right? And in my experience, I am actually a AWS certified solutions architect. And in my experience, if you have a lot of hands-on practice, if you've actually used AWS for a length of time, right, and you've actually solved tricky technical and business problems using AWS, then you are in a good place to get AWS certified, right? Okay, I hope that answers your question. Please let me know. Okay, Shyam, your question is how is AWS developer certification different from the AWS, I guess, solutions architect? So, look, developers, it's just a difference in the emphasis, right? There will be a lot of content and areas of overlap, right? But the emphasis will be be different. So, for example, a solutions architect will be more concerned about how to architect a high availability application what are the building blocks to be used, how will they be connected and configured with each other, right? Whereas a developer will be concerned about things like continuous integration, right? How do you, once you have an AWS infrastructure and you're changing your application all the time, how do you make sure that you deploy those changes to your production environment, right? So it's basically a difference in the emphasis, and also, of course, the roles are different, right? The jobs are different. An architect is involved very early on in a project, right? When you're designing and architecting a solution. A developer is involved later on, and especially during the early deployment as well as the ongoing maintenance of the infrastructure. All right. I hope that answers your question, Shyam. Okay. All right, guys. So let me just go ahead with today's module. So today we're going to look at a few things. One, cloud concepts, definition, terminology, the basic concepts. We look at things such as key attributes or characteristics of cloud computing. We look at cloud computing service models, cloud computing deployment models, right? So these are the cloud essentials, as we like to call it. And then we look at AWS. AWS is not, is one part of the cloud computing industry, right? So once we understand cloud computing concepts, we can look at AWS, what it is not, and we can look at its suite of offerings, right? And once we do that, we'll look at the business side, the market side. What's AWS's position in the cloud computing industry, competitive position? Who are the AWS customers? What types of companies are using it? What are the common use cases, right? And also cloud computing in AWS. What's happening on the job market, right? From a job or career point of view. So essentially, today is a day where we look at cloud computing concepts and we look at the business and market side of AWS. All right, so let's start with definitions and concepts, right? As you can see on the slide, I just want to highlight a few things. By the way, guys, let me just, before we get into this, let me just ask you guys a couple of questions. Can you please let me know what is your experience with cloud computing and AWS in terms of years? This will allow me to sort of tailor my presentation to you guys better. Are you completely new to cloud computing in AWS, or you already have some experience under your belts? All right, okay. So it looks like most of you guys are relatively new, right? The second thing I want to ask you guys is, are you on the enterprise side? For example, are you in a large company, or are you more in a startup or a smaller company? Okay, so a couple of you have responded on this question, and you're saying enterprise. So that's pretty interesting. All right, so now let me go ahead. So I want to highlight a few things here on this definition slide. One is cloud computing refers to on-demand delivery. All right, and what this means is you want a server, you get it right away. Okay, it also means that if you don't want a server, you can give it away right away. Okay, that's number one. Number two, these services are available over the internet. Right? So you just need a web browser, you need an internet connection, and you can sort of request infrastructure, computing infrastructure or storage infrastructure. Right? That's the second interesting thing. And lastly, pay-as-you-go pricing. What this means is this is like your electricity bill or your mobile bill, right? So the more you use, the more you pay, and the less you use, the less you pay. Okay, and if you compare this to traditional buying of hardware, right? I don't know how much experience you have with that sort of thing, but I have some experience, and what typically used to happen was if you needed hardware, say you needed some servers or you needed some storage, you would spec it out. You would write down what exactly you needed. You would invite quotations from multiple vendors, and then you do a comparison of the quotations, and there would be some negotiation. You'd place an order, and then in a few weeks you would get delivery of your hardware, right? And then once you got your delivery, if you wanted to change your mind, there was you had to go through the procurement cycle once again, right? And also, as you might imagine, the pricing used to be quite large, and usually you had to pay it upfront, right? You would pay the money first along with your order, and then you would get your hardware, right? So that is traditional procurement. And then now if you look at things like on demand, right, you get things right away instead of having to wait for weeks. You make your purchases over the internet, right? You don't have to call any distributor or dealer, and it's pay-as-you-go pricing. So it's a post-paid monthly billing, and you have nothing to pay upfront, right? So this is basically the definition of cloud computing. Let's take a closer look at all these things. So first of all, on-demand provisioning, right? This is what this means is you need something, a server, you may need 10 servers, right? And you can get it right away. And if you don't need it, you can terminate it, you can throw it away immediately, right? So again think of traditional purchases, and you can see how cloud computing is better. The second point is also very important, scalability, right? So you can scale out, which means you can go from one server to 10 to 100 to 1,000, right? Potentially you can even get 10,000 servers as well with cloud computing. And similarly, you can scale in, which means if your business changes, you don't need that much of hardware. You can stop using all those 1,000 servers, right? You can come back down to 100 and then down to 10 servers easily. Similarly, you can scale up or down. Okay, what this means is you can go from a very small server, which could be say half a GB of RAM and one CPU, right, to something very large. You could go to 64 GB RAM and 8 CPU. And even larger, you could go to say 256 GB of RAM and 64 CPU, right? So all these things are possible in cloud computing and AWS with a few clicks of the button of the mouse, right? And again, think of traditional purchases, right? If you want to buy 100 servers or 1,000 servers, you can imagine the time it takes and the cost, upfront cost in doing that. All right. The third point is there's no long-term commitment and no upfront capital, right? So first of all, when you buy hardware in a traditional procurement cycle, the hardware is yours forever, right? So you tend to pay a lot of money. It's essentially a permanent long-term commitment to the hardware, right? And for all those years of use, all the money is paid upfront, right? So it's typically a rack server or a high-end server would cost lakhs of rupees, and you would pay all of that upfront, right? But with cloud computing, there's nothing like that. There's no way. You don't need to pay lakhs of rupees in the beginning. You use what you need, and then you are billed at the end of the month. And typically, it's a much smaller amount, right? And you have the flexibility of stopping the usage of these servers. And when you do that, you're not billed at all. Okay, so these three, I think, are key ideas that I would like you to focus on, right? When you compare cloud computing to hardware purchases, and these are the major reasons why cloud computing is such a big trend, right? And there's no doubt that cloud computing will be very widely adopted for the next several years. The adoption is going to only increase, right? And the traditional hardware purchases will probably completely end. The next few slides, I think, explain really well. You know, these are actual examples, okay, of the benefits of cloud computing. If you look at the image on the left side, this is a real-life application in the financial services industry, and you can see the chart. The application is used during business hours, right, and during business days. So basically, it is used for 8 to 10 hours during 5 days in a week, right? And you can see during that time, they use about 3,000 CPUs, right? And during the night, they use only about 300 CPUs, right? So that's the nature of the usage and the nature of the business. You can also see that during a weekend, right, Saturday and Sunday, sometimes there can be a long weekend. They don't have to use those 3,000 CPUs. They just use the 300 CPUs, right? And what this means is they are not billed for those 3,000 CPUs all the time. They are only billed when they are using those 3,000 CPUs, right? And you can imagine the cost savings that they have because of this sort of usage of their cloud computing infrastructure, right? So this is a very good example. And the second example on the right side is a video application, right? And what happened here is for some reason, perhaps there was a modification on Facebook. For some reason, this video application became very popular in a very short time. As you can see in the chart, in a period of 3 days, they went from essentially hardly any usage to a very high usage. And you can see at the peak of the usage, they needed 5,000 servers, right? So they essentially went from maybe 10 or 20 or 100 servers to 5,000 servers in 3 days, right? And this is possible using AWS and EC2, right? And now you can think of the traditional hardware purchase, right? Just imagine asking your HP dealer or IBM dealer to give you 5,000 servers in 3 days, right? So it's completely not possible. Okay, so I think these are a couple of very good examples. Guys, if you have any questions on these, please let me know. I also want to cover this slide. This is again a very strong reason for using cloud computing. Right? And you can see the comparison here. When you have your own infrastructure, right? If maybe you have a server room or you have your own data center, there is a lot of time and energy and resources and people that goes into things like making sure the cables are fine, making sure you're replacing the hard disk when there's a hardware fault, right? So there's a lot of work involved in running a good data center, but the problem is it's undifferentiated, right? And heavy lifting. Heavy lifting basically means it's a lot of work, and undifferentiated means that your business is not benefiting from doing this work, right? It doesn't give you any competitive advantage because everybody does the same thing, right? What cloud computing does is it completely changes the equation, right? So now AWS does that heavy lifting for you, right? And all you have to do is configure your cloud assets, And this configuration is what you're going to learn in this course, right? It's basically about how do you structure your infrastructure, right? You want 10 servers, you just say you want 10 servers of this this size and this operating system, right? So it's basically configuring that you will do. And configuration requires way less time and less effort compared to actually maintaining the hardware infrastructure, right? So it changes, it reduces your effort significantly, so that you can focus your effort on your product, right, on your business, and that is where the differentiation is, right? That is what will make you money. That is what will make you succeed in the marketplace, right? And I can vouch for this. I actually started using AWS when I got frustrated with running our applications in our own server room. We had server rooms in a small data center in the Seeps area of Bombay. This is an export processing zone, and supposedly there's no power outage in Seeps, right? But we faced all kinds of problems with power. We had battery for 8 to 10 hours. There were situations where that was not enough. We had outages with the internet connections, even though we had internet connections from two different providers, right? So we simply could not have a high enough uptime. We felt we could not offer a competitive quality of service to our customers, right? And that's when I switched to AWS, and there was a whole world of difference between doing it on your own and using AWS. All right, so I'm going to stop here because this is, this slide is my last slide on cloud computing concepts. Please let me know if you have any questions. So this is basically, the key attributes or key characteristics of cloud computing and how this is different from traditional data centers or traditional hardware purchases. Okay. Okay, so if there are no questions, I'll move on. So the next topic is the different types of cloud models, and a good term for this is a deployment model, right? How do you deploy your cloud computing infrastructure? And there are a few ideas here on this slide you can see, right? There's first of all the public cloud, and the second idea is the private cloud, which is essentially the opposite. The third idea is hybrid. This is basically private and public combined. And lastly, a community cloud. Okay, so let's try and understand each of these because this is of significance to you, since most of you seem to be saying that you are in the enterprise side of things, right? So private cloud and hybrid cloud will be of interest to you. If you look at the right side of this slide, right, you can see the public cloud is off premises, right? It's not in your data center. Okay, it's out there somewhere. It's say in Amazon Web Services data centers, or if you're using Azure from Microsoft, it will be in Microsoft's data center somewhere in the world, all right? But if it's a private cloud, you probably will have it in your own data center. It will be either in your own office or it will be in your own data center if you're a large enterprise, or it could be in a third-party data center, but you have a lot of control over those assets, right? So that's basically private cloud. Now, remember, both of these are cloud, so they have the same characteristics of elasticity, for example. Right? They have the same characteristics of on-demand provisioning. Okay, so both of these have the same characteristics, but there is a difference in terms of the security and the ownership. Okay. Anyway, let's take a look. You can also see on the slide, on the right side, that there's the hybrid cloud is basically a combination, right? So there's private cloud, which is on premises, and there's public cloud, which is somewhere in third-party data centers. And there is some sort of connection between the two so that you can transfer applications and data between the two clouds. Okay, so that's what hybrid is. Let's take a closer look. So here's the definition of cloud computing. This is the standard thing. Public cloud is AWS and all the major cloud services are essentially public cloud. Okay, so these are dynamically provisioned, on demand. They are self-service. They are over the internet, right? And they are built on a utility computing basis, right? So this is the standard cloud. This is what everybody understands as cloud computing. Okay, now the question is, under what situations or circumstances is a public cloud used? So first of all, if you have something which is used by a lot of people, right, outside of your own company, right? So typically say it's a consumer application like Flipkart, right, or Redbus. So it makes sense to have it on the public cloud, right? So if it's on your own data center, you have to worry about things like access control. Perhaps you have to open up the firewall ports, right? You have to allow access from. So that's what public cloud does anyway, right? So so a consumer application which is used by a lot of different people outside your company is a good candidate for a public cloud deployment. The second example here is also interesting: a test application environment or a development environment, right? Now, why this is a good candidate for cloud computing is because you need test servers on a temporary basis, right? You need it for a month, and then for the rest of the 11 months in a year, you may not need it, right? Or you may need it for 3 months in a year. Whenever there's a temporary requirement, it makes sense to use the cloud, because cloud allows you to throw away the infrastructure when you don't need it. All right. Software as a service is again an example where it's used by a lot of people. You may have users from around the world, right? You want users from around the world. So that's a good candidate for public cloud. If you need incremental capacity, right? So you have the infrastructure you need on premises or in your own data center, but there are certain peak usages, right, where you need some additional capacity, right? So why buy it when you have to throw it away, right? It's better to use the cloud in such scenarios. Okay, so I mean, if you run through these applications, right, you'll see a pattern emerge. One is if a lot of people outside your company use it, right, and you need to give them access from many different places around the world, around the country, then cloud is a good thing. If you need infrastructure on a temporary basis, right, or if there's spikes in your usage, that's another good use case for public cloud. All right. Any questions? Okay. Let me go to private cloud. So this is essentially infrastructure which is maintained on a private network, right? And what this private network means is it is isolated, right? You have a network, let's say you have a LAN, right? Or you have your own server room. It's not connected to the internet. Okay, so that's what a private network means. And of course, they offer the greatest level of security and control, right? But there is a downside. And that is because it is only for you, you have to bear the cost of all that infrastructure, right? So there's no sharing of costs across multiple companies, right? So private cloud is usually much, much more expensive. Okay, and like it says here, it's a private cloud is usually a first step for a large enterprise to adopting a public cloud infrastructure, right? And cloud in itself has some benefits, even if it is not public cloud. Features such as on-demand provisioning, right? Self-service, the virtualization of hardware. So you can have many applications on the same hardware. So you get some cost benefits, right? But not to the same extent as with public cloud. All right. So what are the use cases? What are the circumstances or situations where you should use the private cloud? So typically it is, if you are in a large enterprise, you already have your own data center, and also regulated industries, right? So financial services, banking, insurance, healthcare are industries which are heavily regulated by the government, and data protection, data privacy are big concerns, right? So credit card information, credit score or credit history information, medical record information. These are very serious matters, and there is a reluctance from such companies to move to public cloud infrastructure such as AWS. All right, and of course, the company has to be large enough. Say a large bank, a US bank, would have the capability to sort of have its own cloud data center, right? So there it definitely makes sense. All right, any questions on the private cloud? Okay, let's look at hybrid cloud now. So, a little bit of history here. See, cloud computing started with the public cloud, right? And it is when companies such as AWS wanted to expand their offerings, their markets, right? And when they started to go and speak with financial services companies or healthcare companies or government sector, right? Usually who are slow adopters of new technology and who have a lot of concerns around data protection. That is when this idea of private cloud started to gain currency, right? And as you have seen, private cloud is more secure, is better from a regulatory point of view, but is more expensive, right? Public cloud can be perceived to be less secure, right? Can be perceived to be less compliant with regulations, but it is definitely cheaper simply because the infrastructure is shared across many people, right? So then after the private cloud idea came about, this is when the hybrid cloud idea also came about, right? Because people started to say, why can't we have the best of both worlds, right? So whenever applications or data is sensitive, let's keep it on the private cloud. And even in regulated industries, right, there are certain applications and data which are not very sensitive. Let's keep those in the public cloud. All right, so that's how this idea of hybrid cloud has come about, right? And you can see on the slide there are certain good examples. For example, a disaster recovery site, right? So you could have your primary data center as a private cloud, but you could sort of provision some infrastructure in the public cloud to be used in case of a disaster, right? So you can have some servers configured. You could sort of keep them shut down, right? And then if there's a disaster, you could sort of bring up the public cloud infrastructure for a short duration while you recover, right? So there is an advantage. There is some loss of privacy and some loss of data protection, but at least the cost of the disaster recovery site is not very high, right? The second example that is given here is backups and also test and development environments, right? Because test and development environments are usually temporary. You can make sure that the data in the test and development environments is not sensitive, right? I've worked in a bank. What we used to do is anonymize the data, right? So none of the production data used to get into test and development environments. And if it did get into test and development environments, it used to be anonymized or masked, which means we used to sort of remove things such as card numbers or names and addresses. All right. So this is what a hybrid cloud is. You try to offer the best of both worlds. All right, guys. Any questions? Okay. All right, so this is, I'm not very familiar with the community cloud idea, but basically this is also something in the middle, something between a private cloud and a public cloud, where it's not completely public. The infrastructure is not shared across anybody from anywhere in the world. The infrastructure is shared, but only among known set of companies or organizations, right? And in my experience, I've seen some examples of this. For example, universities coming together to set up a common catalog of their of books in their libraries, right? So this is one example that I have seen. And on this slide also you can see there are some examples mentioned, especially around the open source projects. All right, so this completes our discussion on the deployment models for cloud computing. Okay. Now let's look at types of cloud services. You can also call these service models, right? So these are cloud computing service models. And there are three ideas here on this slide. One is infrastructure as a service. The other is platform as a service. And the last one is software as a service, right? And these terms have been confusing. You know, for people who are new to cloud computing, you know, these are sort of people are not able to differentiate between these types of offering, right? And if you look at the right side of this slide, this should give you some hint. As you can see, the client or the end user is communicating only with the SaaS layer, right? Software as a service layer, but is not communicating with the platform as a service or the infrastructure as a service layer. Okay, let's try and look into these. Please note that all three have the last three letters are AAS, as a service, right? So basically, all three share the cloud computing characteristics of pay-as-you-go, elasticity, on-demand service, right? All three are the same in that respect, but they are different in a few key aspects. Okay, so first of all, infrastructure as a service, right? And here, what is happening is you can request for raw infrastructure, right? So typically, you can request for a server, right? You can say, hey, I want a server with 1 CPU and 1 GB of RAM, right? You can do that. Or you may say, look, I am looking for storage, 500 GB of storage for my log files, right? Or for my video files, right? Or you can ask for other types of infrastructure as well, like load balancers or IP addresses, right? Or network subnets, right? So these are sort of raw computing, storage, or network infrastructure, right? And usually, cloud computing uses virtualized assets, right? Virtualized infrastructure. So it's a virtual server, or even the storage is a virtual storage that is issued. Okay, so this is infrastructure as a service. Platform as a service is the next layer. Essentially, the platform does more things for you. It does some of your work, essentially, right? So not only does it give you the infrastructure, it does additional things such as it may take care of security, for instance, right? It may take care of reporting for you. It may give you the packages, the application packages such as Java packages or the LAMP packages, right? It may have them pre-installed and pre-configured. It may give you a database pre-installed and pre-configured, right? It may do a monitoring of your infrastructure. It may do billing of your infrastructure. It may take care of scaling, right? Horizontal scaling or vertical scaling. So essentially, a platform as a service does some work for you. It makes your life easier. It helps you deploy or implement your systems faster, right? So they add value and on top of the infrastructure that they provide. Okay, so that's a platform as a service. All right, and typically the platforms are targeted at developers or technology companies who are looking to build their applications on top of these platforms. Right, so normally you don't find end users using platform as a service. It's typically the developers and technology companies. And finally, software as a service. So this is the service model where the target customer is the end user, right? And as you can see here on the right side, you could be a user in the finance department or the HR department, right? And you're probably looking for an accounting package or a leave management package, and you are only interested in using the software, right? Just the functions of the software. You're not really worried about what's happening behind the scenes, right? So you're not worried about whether this is a Java application or where the servers are, right? Or how many servers are being used to provide this service, right? So that's software as a service. All right, guys. Any questions on this concept? Essentially, these service models. Okay, so let me ask you a few questions, right? Just to reinforce the learning, and perhaps we can have a discussion around this. Can you guys give me some examples of software as a service that you are aware of? Perhaps you're using them. Okay, yeah. So Sasanka is saying Salesforce. Sunil is saying HRMS. Bhaskar is saying Google Docs. And absolutely, I think you guys are absolutely right. And Salesforce is a very good example because this was an early leader. It was a software as a service pioneer, and of course, it's a very dominant company right now. But the same thing, whether it's accounting package or HRMS, they can all be deployed in a SaaS model. Google Docs and especially Google Apps, right? Google Apps is a full suite of SaaS applications, including Gmail, right? All these things are also very good examples of SaaS. And as you can see, SaaS is the largest sector in the cloud computing industry, and enjoys widespread adoption. Okay, let me ask you another question. Can you guys give me some examples of platforms as a service that you guys are aware of or perhaps have used? And Shyam has given an example of a tax calculator as an example for a SaaS, and of course, any kind of business function that is delivered over the internet, over the web, can be considered SaaS. Okay, now you guys are giving me examples of PaaS. So Shyam has given an example of OpenShift. Sasanka is saying Salesforce and Google. Shyam has given Azure as well, and Sunil is saying Jenkins and GitHub, SVN, and Ansible. Right. Okay. So Azure, I think yes, definitely. I think Azure can be considered a PaaS, and perhaps it can be considered infrastructure as a service as well. Salesforce can be considered a platform, because you can build several things around the core Salesforce application or platform. That's definitely there. Google itself, I think Google App Engine right? I don't know if you guys are familiar with it. Google App Engine is a good example. It's a very good example of a platform as a service, right? And as far as GitHub and SVN, well, I guess sometimes the lines are blurred, right? Sometimes it's not very clear. GitHub could be considered a SaaS as well, right? Because you're using it as an end user, right? So anyways, I think these are good examples. Let me ask you another question here, right? Why do you think Google App Engine, which is a platform as a service, why do you think it did not become very popular? Okay, so let me answer this one, right? So Google App Engine was promoted as a platform as a service, right? And if you guys are not familiar with it, let me tell you how it works. Basically, you just create your application, right? It could be, say, a Python application, and then you upload it on Google App Engine, and it takes care of everything else, right? It sets up the database, it sets up your Python environment, it sets up a web server, it takes care of scaling up of the infrastructure, right? It does everything for you, right? But it did not become popular, and the main reason was there was a sort of a lock-in, right? So, for example, if you changed your mind and you wanted to move from Google App Engine to AWS, right? You sort of, it was hard. It was not easy. You would have to do a lot of changes to sort of move away from Google App Engine, right? So this is one of the problems with platforms as a service, right? The lock-in aspect. If you compare that to Amazon Web Services, you basically get the raw infrastructure, right? So you can sort of set up an Ubuntu server on AWS, and then if you decide to change things, if you decide to move your application away from AWS, it's pretty simple because it acts very similar to your own server or your own infrastructure. All right. Okay. Let me also, guys, ask you. Okay, sorry, I'm getting your responses a little late. So Sasanka is saying proprietary code which will not work on another cloud. Yeah, exactly right. So that's what I was explaining. There's a kind of a lock-in with Google App Engine which made it less popular. And Sham, you're saying it did not have flexibility and enough scale and monitoring aspect. No, I'm not sure. I think from a scalability point of view, I don't think there was any problem. Google would take care of it. It's I think mainly the lock-in aspect which was the problem. Okay. Okay, let me ask you guys one more question. Do you think AWS is infrastructure as a service, platform as a service, or software as a service? Okay, so Sasanka, you're saying it's infrastructure. Sham, you're saying it's both infrastructure and platform. And okay, so I think the answer is both. Yes, it is infrastructure and platform. But remember, when it started out, it was mainly infrastructure as a service, right? Because it offered things like um, uh, EC2 instances, which is basically servers. It offered S3 storage, elastic block store, which are basically like hard disk, right? So these were infrastructure elements. And in the recent past, they've added platform capabilities, right? So something like a relational database service is where you can manage your databases, but it does things more than just giving you infrastructure, right? So an RDS, for example, takes care of backup. It takes care of database replication, right? So it does some extra work for you, and therefore you can consider some of AWS's services to be platforms. Okay, so good. I think you guys are um, aware of cloud computing concepts to some extent. That's a good thing. Okay, let's look at this slide here. This gives you a good idea of some key players in the cloud industry, right? And this also covers some of the discussion we just had. For instance, if you look at the infrastructure as a service row here, right? You can see AWS, and like we discussed now, right? It probably should cover both platform as a service and infrastructure as a service, right? And you can see here Google App Engine. This is listed as a platform as a service, right? We know that. Another very good example is Heroku. Right? If any of you guys use Ruby on Rails, right? Heroku was or it still is a very popular platform as a service for Rails applications. But now they also have other sort of programming languages, right? They also support Node.js, Java, and those sorts of things, right? But this was one of a pioneering company in the platform as a service space, right? Azure, like we discussed again, I'm not sure it's only a platform as a service. Perhaps it can be considered infrastructure as a service also, right? Um, and the examples that you guys were giving, right? It's they are right here. There's Google Apps in the SaaS row. There's Salesforce, and you also mentioned HRMS. So you can see there's Taleo, which is a major player in the HRMS space here. Okay. Now, a couple of things, because you guys said you are more on the enterprise side, right? You might be interested in the private cloud, hybrid cloud sort of things, right? So what you should do is take a look at some companies in the cloud platform row, which is below infrastructure as a service. Okay. What you should do is, if you're not familiar, you should look at OpenStack. You might not be able to see this logo very clearly, but this is here on the right side. OpenStack is an open source Apache Foundation project, right? And Apache Foundation, as you know, Apache Web Server, Tomcat Server, the same foundation. And OpenStack will allow you to create your own cloud environment, a private cloud environment. Right, so it's definitely something that you should sort of look at and see if it is useful in your company. Okay, another example is Eucalyptus here in the middle. This is also a way for you to create your own cloud computing platform, especially if you want to create a hybrid cloud computing platform, right? So a mix of private and public, and Eucalyptus works very well with Amazon Web Services. All right, and I think there's a lot of movement. This is a little dated, this slide, and there's a lot of acquisitions happening. I think Eucalyptus has been acquired perhaps by HP, I think. Okay. Okay, Sham is saying VMware, right? Now, definitely, VMware at one time, several years back, was had the highest market capitalization in the world. Okay, VMware was a real innovation at one time because, and this is basically, virtualization as a technology, right? So VMware was a pioneering company in the virtualization space, and the idea was before virtualization, what used to happen was you used to buy very big servers, right, from these big vendors, IBM, HP, etc. And what would happen is most of the servers would be utilized very less, right? Most would have utilization of maybe 1%, 5%, something like that. And then VMware came along, and their idea was we will create virtual environments, right, on the same hardware. So that on the same hardware you can run maybe an application on Ubuntu. On the same hardware you can run another application on Windows, right? So VMware allowed the reuse or the better utilization of hardware, right? And it could, using this technology, save large enterprises millions and billions of dollars in hardware cost, right? So that is why VMware was a very successful, very valuable company, and it still is. Right, but it basically is a virtualization technology and a virtualization company. Cloud has gone a little bit beyond that, right? Cloud also, even AWS, for example, uses virtualization, definitely, right? But the features that cloud offers, things like on-demand, elasticity, those are sort of beyond virtualization. Okay, Sasanka, you're asking what is the cloud marketplace? Yeah, so outside of this these key areas, right? SaaS, PaaS, infrastructure as a service, and cloud platforms. There are others. For example, the marketplace and brokers. These are sort of kind of players more on the selling side, right? So a cloud marketplace is a platform where they help people buy cloud products, right? So it could be SaaS, PaaS, infrastructure, and they basically add a layer of things such as maybe a little bit of consulting, a little bit of advice. They may have things like comparison, right? They may compare prices, they may compare features of various cloud offerings. So it's basically a marketplace like Amazon or Flipkart, but for cloud products, right? And they have a role. They have a role to play in the ecosystem. Right, and if you are a SaaS company, for example, right, if you are building your own SaaS product or your own PaaS product, of course, SaaS is much easier, right? Most people, anybody, a small company can build SaaS. Building PaaS and infrastructure as a service is very hard. So most likely, if you're a SaaS player, you should look at marketplaces as a business development opportunity, right? You can get listed there. You can give your product descriptions, perhaps give interviews, and hopefully get resellers, right? So you may have resellers in the US market who can sell your product. So those are the things that marketplace does. A broker is something similar. It basically, they try and add a layer of advice. They can combine offerings from multiple providers, right? So for example, you may be a company that needs a little bit of public cloud and a little bit of private cloud products, right? So a broker will give you one interface, one console or one single interface through which you can monitor, manage infrastructure from multiple providers, right? But again, they're also more on the selling side and help people buy cloud products. Okay, and while we are here, we should also look at this cloud management row, which is the third row, right? And you can, one company that I'm a little bit familiar with is this company called Cloudin, somewhere in the center here. And what they do is basically help you manage your cloud infrastructure better, especially from a cost point of view. And like I was saying before, the billing of cloud computing can be a challenge because it's like a postpaid mobile connection, right? You can be surprised by the bills, and you often, especially in the earlier years of AWS, it was very hard to know why the bill was high, what you could do to reduce the bill, right? So those are the kinds of offerings that these cloud management companies were bringing in. But now, if you see AWS, right, they have expanded their offerings. They have their own tools for managing cost, right? So some of these things I think will go away, and you'll find more and more tools and better tools within Amazon Web Services itself. All right, so this I think is a good slide. It gives you an overall picture of the cloud computing industry. Right. Okay. And here's a very interesting question. Shyam is asking here, who is the provider of hardware for Amazon? That's a fantastic question, and I'll tell you why. Although this slide shows IBM and Dell and Sun, right, and HP, right? These are the major vendors before cloud, right? So these were the guys who were supplying hardware to data centers and large enterprises, right? But in the cloud, this trend that is taking off, right? This complete change in how people do their infrastructure. These are the players who are the losers, right? Because they used to sell a lot of expensive hardware for a lot of money, which was paid to them upfront, right? And cloud, as you saw in the previous slides, the cloud has completely changed that. Right? People don't pay large amounts of money. They don't pay anything upfront. They only pay on a monthly basis, right? So these companies actually are the losers, and the reason is people like AWS or people like Azure, right, or people like Google App Engine. They don't use IBM products. They don't use HP products or Sun servers, right? They use what is called commodity servers, which is basically they're just boxes. You can sort of get Intel chips from China, and they're completely commoditized hardware, right? They may not be that robust, right? But it doesn't matter because AWS would sort of automate all this, right? Their data centers would run in a way where if there's a hardware failure, right? If one server goes down, they have software which detects that a server has gone down and it can sort of replace it, right? It connects to another server to replace the one that has gone down. So they don't need high-end servers from the likes of IBM. All right. So Shyam, I hope that answers your question. Okay. So I think this is a fantastic slide because it gives you a picture, right, of the industry, and as developers, I think it's very important for developers, even though you are more concerned with using the technology. I think it's important for developers to be aware of the context, the overall market, and the overall industry, right? All right. So now let's kind of look at. We are at a logical break, right? Do you guys want a 5-minute break? So we've covered about 1 hour 15 minutes. If you guys want a logical break, we can take a break of 5 minutes and come. Okay, so now we've looked at cloud computing as a as an industry and conceptually. Let's focus on Amazon Web Services. Right, and as we've discussed, it's both infrastructure as a service and platform as a service. And they have AWS has various offerings. Right, let me show you my console. Right, and this is what you will see if you sort of create your account, and you can see there's a whole set of very large set of offerings, right, or services. And they are categorized under various heads, right? So you can see there's a compute section, there's a storage section, database, and so on, right? And this was not always the case. They started out with a few infrastructural elements, especially there was EC2 in the compute side, and there was S3, which is a simple storage service on the storage side. And there was no VPC, for example, right, in networking. But they have been expanding their suite of services at a very rapid pace, right? And today this is where we stand. There's virtually anything that you might need, you'll probably be able to do it with AWS, right? And they've also targeted big areas such as big data and analytics, right? So they have services in that space. They've also targeted mobile development, right, which is also a very big area. And you can see these are sort of new services here on the right side, which they've launched for mobile. They have something for Internet of Things, right? So they're trying to cover all the major trends, right? But let's look at each category in a little bit of detail. All these services we are going to cover in more detail tomorrow, right? So at this time we'll just look at them at a little bit high level. So first of all, you can see the first section is compute, right? So this is one big category, and essentially it is CPU, right? Or you can think of these as servers essentially. So there's CPU plus memory or RAM, which is available under this section. So the most common use right in this section is virtual servers. Right, so this is very similar to the VMware virtual server, except that you can get any number of servers and you can get any type of server over the internet, right? And this service is called EC2, Elastic Cloud Compute. And anything that you do on AWS, you'll probably be using EC2, right? So this is something that you should really master and really learn about. Right, but there's also other things like containers. This is also very new offering from AWS. And if you guys have heard of Docker, right? This Docker is a new concept, which is like virtualization, but virtualization is where you can run multiple operating systems on the same hardware, right? But what Docker does is you can run multiple applications in the same operating system. Right, so it's like virtualization, but a little bit different and a little bit better, and it gives you an opportunity for further cost savings. Right, so if you use Docker or containers, AWS has an offering for you. It also has something called event-driven compute function. Right, this is also a new offering. It's called Lambda, AWS Lambda, and what this does is if you have any business logic, any kind of function, right? Say you want to send an SMS, right? Or you want to send an email. Then you can just write this function, upload your code. It could be, say, a Ruby code or a Java code, and this function can be called, let's say, over HTTP, right? So there's a way to sort of call this function, and whenever this function is called, AWS will set up the computing required to sort of perform that function, and the function may run for a few seconds, and then it does the job, right? So you can send an SMS or send an email, and then that's it. So you'll be billed only for those few seconds, right? So essentially, this is a new kind of offering where you can really break your application into tiny functions, right? And you only pay for the amount of time that those functions run for. This is a very new kind of concept that they've come out with. Auto scaling is something very interesting. This is not new. It's been around for a while, but perhaps not used as much as it should be, right? And what this does is you can create an infrastructure where if your usage is changing a lot during the day, let us say, right? In my experience, we had an application where the usage was highest in the evening, say between 7 p.m. to 9 p.m. right? And then the rest of the day was pretty normal, average usage, and there was no usage in the night, right? So if you have this kind of spiky application usage, then auto scaling is a good option. And what happens is AWS can automatically add more servers, right? If the usage increases. Right, so you can set up a pool. You can say minimum of 2 servers, maximum of 50 servers, and then as the usage increases, it keeps adding servers up to a maximum of 50, right? And then late in the night, when the usage has collapsed, right, there's no usage, it will automatically reduce the number of servers so that you don't get billed, right? So this is a great way to have a high-performing application, right, to give the users a great experience in terms of performance and response time, but also a great way to save infrastructure cost, right? So I would really recommend that if you have applications where usage changes a lot, right, within days or across a longer period, you should consider auto-scaling. Load balancing also is a very important feature or an offering, because in any application, if you need to create some sort of high availability infrastructure, right, and then you need to have multiple servers, right? So maybe your web servers or your web server layer or your application server layer, you should have multiple servers, because if you just have one and that hardware has a problem, right, or that server has it can have all kinds of problems. So in my experience, we've used servers where the memory used to get maxed out, right? So the server used to become unresponsive. This used to happen very often with our type of application. So having multiple servers is definitely useful, right, from an availability and an uptime point of view. But as soon as you have multiple servers, you do need to have a load balancer that will distribute load to these multiple servers, right? And often, if you want to create a high availability infrastructure, you can have your servers in different data centers. So let's say you have 4 servers, then 2 can be in one data center, 2 can be in another data center. AWS has something called availability zones. These are basically different data centers in the same region. And then again, you need a load balancer to sort of distribute the load, right? So and finally, things like one-click web app deployment, right? So this is where, although this is the compute side of things is mainly infrastructure, one-click web app deployment is, there's a service called Beanstalk, Elastic Beanstalk, which allows you to sort of quickly deploy your application, right? And common applications such as Drupal content management system, right, is available readily, and with just one click you can sort of deploy such an application, right? So here is where it becomes slightly more a platform as a service instead of just infrastructure as a service. All right, so this is the compute section. Do you guys have any questions here? Okay, let me go ahead, and you can see here, this is my dashboard again. You can see in the compute section there are 4 offerings right now. EC2, which is virtual servers. This is the Docker type of container service. Beanstalk makes deployment and management of your application faster, right? And Lambda is the function, right, that you can run, like a granular individual function that you can run, and you only pay for the amount of time that the function runs for. Okay, let's look at storage. Right now, remember, when we talk about infrastructure, compute is one type of infrastructure, and storage is another very basic type of infrastructure, right? And there are several storage options with AWS, right? And each has different characteristics, each has different pricing and cost implications. So you need to be aware of this, because no matter what you do on AWS, you will be using some sort of storage, right? And you need to really understand the different types of offerings here. So first of all, there is object storage, right? And this is referring to a service called S3. A simple storage service. One of the older services, very popular. You'll most likely use S3 in some way or the other, right? And object storage basically means there is data, right? It could be, say, a video file or image file, and there is metadata associated with it, right? And these objects are stored in what is called a bucket in S3. And then you can sort of control access to the bucket. You can sort of decide who to give access to or whether to make it public, right? And the size of the objects can be very, very large, right? So it's a great offering if you have video files, large image files, log files. Those things can be easily stored on S3. Right, but the performance, the retrieval performance is not great. So it's not meant for all kinds of use cases. Okay, the next option is block storage. So this is just a raw block. Block storage is, I think the easiest way to think of this is to think of hard disk volumes, right? So the performance is good, but there's no metadata that goes with the content, and typically the operating system manages the block on your hard disk volume, right? So this is basically a service called Elastic Block Store, EBS, and EBS is basically like your hard disk volumes, and these volumes are attached to your EC2 server instances, right? By the way, both object storage and block storage with AWS have very high reliability, right? So it's very unlikely that you'll lose your data. I think S3, the object storage, has a guaranteed, the chances of data loss are very, very small. I think it has something like a SLA of 99 point several nines. I think there are 6 nines after the decimal. So it's a very reliable means of storage. Block storage also is very reliable. Although in block storage, the data is replicated only within one data center, right, in one availability zone. In the case of object storage, the database is replicated across multiple data centers, right? So object storage is more reliable. Okay, there's a new offering for file system storage. File system storage is like your Windows files, where in the olden days within a LAN you could sort of share files, right? So this is the kind of offering that has come out from Amazon. It's not yet available in all the data centers, but it's something that you can explore to see if it is useful to you. Okay, the other couple of interesting things are archive storage, right? So these are, let's say you have old database backups, right, which are, say, 30 days old or 6 months old, and you may need to keep them. You may never sort of retrieve them, right? You may never need them, but you still need to keep them for maybe regulatory purposes or for record keeping, right? So basically, you just need to store them, and you need a cheap, very low-cost way of doing that. So there are offerings like reduced redundancy storage, and there's a service called Amazon AWS Glacier, right? So this Glacier is something which is very, very cheap, but it takes time to retrieve the data. So there's a trade-off. Cost is very low, but the time to retrieve is very high. Right, so S3 is expensive, EBS is expensive, Glacier is very cheap, but retrieval takes a long time. All right, and then integrated storage is basically for this hybrid type of cloud environments where you have your on-premises data, and you're sort of replicating it or sort of backing it up on the cloud. Right, so there's a way of for you to sort of couple your on-premises infrastructure with the cloud infrastructure, so that the replication or backing up is sort of automated, right? So that's integrated storage. And then finally, CDN. CDN is a content distribution network. It's called, the service is called Amazon or AWS CloudFront, right? So this is AWS's CDN. And what the CDN does is it serves content such as video files or audio files, right? So if you have, say, a YouTube type of offering, or if you have a Ghana.com type of offering, right, you would probably use a content distribution network, because what it does is, depending on where the user is, it serves that content, because these are heavy files, right, and these are type of streaming type of activities. The user is served from a data center which is closest to that particular user, right? So that's what a content distribution network is, and AWS has an offering for that as well. All right, so these are some of the storage and content deliveries type of offerings. Do you guys have any questions here? Okay, so again, going back to my dashboard, you can see the storage and content delivery section here, and S3 is the most commonly used offering. CloudFront also, depending on the type of application, is quite popular, I would think. You should definitely use this for applications like audio or video or image. Even if your applications are image heavy, CloudFront is something that you should consider. This is a file system offering which is new. You can see it is available for preview right now. Glacier, definitely something that you should look at, because if you want to store old data at a very, very, very low cost, Glacier is something that is definitely useful. Storage gateway is the one that we spoke about, where you can sort of couple your on-premises infrastructure with your cloud infrastructure. And there are other things as well. Import-export is where you can sort of move large amounts of data in an offline way. Right? Essentially, you can sort of send them, post them hardware, so that large amounts of data can be uploaded onto the cloud or downloaded from the cloud. Okay, so this is storage and content delivery, and these two combined, compute and storage, right, are the core infrastructural elements of AWS. Okay, let's look at a special case here, right? This is analytics. And like I said before, analytics and big data are and cloud computing are made for each other, right? And this is because things like MapReduce computing, right, where you need a large number of nodes or servers, and you typically need them on a temporary basis, right? This sort of operation goes very well with cloud computing because it is very elastic, and this sort of thing is very difficult to do in your own data center because it's temporary, right? The infrastructure needs are very large and very temporary. It doesn't make sense to do it on your own data centers, right? So this is a special case, and AWS seems to be doing a lot of work in this area, and you can see they have created a number of services, right? So the first example is Hadoop. Now, I don't know how many of you guys are in the analytics space, right? But it's a pretty big area. And Hadoop is basically a system for doing big data analysis, right? So it does something called MapReduce, which is basically it crunches information in parallel. Right, so Hadoop type of activities require a lot of servers which are running in parallel. All right. Now, what you could do is you can take a lot of virtual servers, right? You could take EC2 instances, say 50 of them, and you could create your own Hadoop infrastructure on top of those 50 servers, right? What AWS has done by offering this service called EMR, Elastic Map Reduce, right? EMR, is basically it has made it easy for you to get your 50 servers, and you don't need to worry about installing Hadoop and configuring it and coordinating all these 50 servers. AWS has all that ready-made available to you. All right, so that's one of the important offerings in the big data space, but also other things like Elastic Search. Right, Elastic Search is again, if you look at things like e-commerce or social networking, there's a lot of data, a lot of big data, and then a lot of this analysis has to be presented via search interfaces. Right, so if you think of Flipkart. And you look at how fast it responds, right? The Flipkart site or the Amazon site, you can search for anything, and there are millions and millions of catalog records, and also the search interface has filtering mechanisms, right? You can filter by price, category, and so on. So that type of search interface requires, especially if the data is very large, right? If your catalog record size is very large, it requires a special kind of infrastructure, right? And it's not easy to recreate. But what AWS does is it offers a search offering where you can just dump your records. It could be catalog records, or it could be any other sort of records with metadata. And within a few minutes, you can have a search interface, right? So it sort of indexes all this data and makes it available to you via some sort of API, and you can use that API in your front end, and you can create a Flipkart or Amazon-like search interface very, very quickly, and you don't have to worry about things like scaling of the interface and so on, right? So this is a search offering, and also other things, which may not be that popular. For example, real-time streaming. Now you have IoT, right? Internet of Things, and there could be sensors which are sending in a lot of data, for example, right? Or there could be data such as clickstream. There could be very large websites like Amazon.com or Flipkart, where a lot of users are sort of clicking on the website, and all that data of what people are doing on the website is sort of being sent. And what you want to do is sort of analyze that data in real time, and then change the behavior of the website. Right? So those sorts of things also fall under this analytics category, and there are certain offerings from AWS around this as well. Right. So you can see here at the bottom analytics, and EMR is something that we spoke about. This is basically a Hadoop framework. And Elasticsearch is again something that we spoke about. And Kinesis, okay, this is what we are talking about here. This is a real-time streaming data related service. Okay, and there's also machine learning, right? This is also sort of very popular nowadays. And you can consider it related to big data and analytics, right? And what happens here is you have a large set of data, and then you have some sort of algorithm. There are many machine learning algorithms that you can find. Some are very popular. They are available in academic papers, and companies like Amazon.com, right? Not Amazon Web Services, but Amazon.com have been using machine learning for a long time, right? And use cases are things like what is the user's behavior on the website, and then you can try and predict whether the person will buy or not, right? And if it looks like he's not going to buy, you can sort of make changes to the experience, right? And sort of drive him towards making the purchase, right? So these sorts of things where you use a lot of data and then sort of learn how to predict behavior. That's what machine learning is. And there are sort of AWS has made machine learning possible on tap, right? So if you try to do this on your own, it could take you a long time. Which algorithms, how to set them up, how to load the data, how to get the system to learn, how to predict, right? So these things take a lot of time if you were to do it on your own. But with AWS, this is available on tap. Also warehouses, right? Warehouses are a very old concept, and there are a lot of products in the market, right? And although big data seems to dominate the discourse nowadays, my friends, at least in the industry, tell me that big data is a little bit of hype, and it's a little bit early. Most people still do warehousing type of activities, right? So there's warehouses are still very popular. People are still doing business intelligence type of reporting, and Amazon, of course, has warehouse type of offerings as well. So this is the one that I wanted to show you, Redshift, right? So this is, it's not categorized here in the dashboard under analytics. It is categorized under databases, but this is the product which is a data warehousing service. And like it says here, it is a petabyte scale. So really large amounts of data can be loaded onto Redshift for analysis. All right. Any questions, guys, so far? We've covered a lot of ground in terms of the AWS services. Okay, let's move on. So this is the next set of the next set of categories, right? And the database as a category is obviously important because most people will use databases. And you can see the first offering is a relational database service, right? So this it's called RDS, Relational Database Service, and it you can have MySQL, you can also have Microsoft SQL, and PostgreSQL and Oracle as well, right? So all the major databases are covered. And now one thing that you must note is you can take an EC2 instance, right? You can take a virtual server and install your MySQL database on that, for example, right? So there's nothing stopping you from doing that. In fact, a lot of people do that, right? They manage their own databases on virtualized server instances on AWS, right? But what relational database service does is that it's kind of a platform as a service, right? It does additional work for you. It makes it easier for you. And what it does is things like backup, right? So you can just configure and say that, look, I want the backup to be taken every night at midnight, and I want each backup to be stored for 7 days, right? If you want a database replication, right, you have a high availability requirement, and you want your database to be replicated between two data centers, right? So relational database service can take care of that. And if you guys have managed databases, right, you will know that this is a very difficult thing. Making sure backups are coming out and making sure replication takes place is a serious and a very difficult task, right? So I would not recommend that you do it if you're a developer, for example, right? It's better that you focus on the application. Under such circumstances, it makes sense to use relational database service, right? But RDS is more expensive than EC2. Right, because they're adding more value, so it costs a little bit more per instance hour than a plain EC2 instance. All right, and similarly, there are other types. So you must have heard of NoSQL, right? NoSQL is a very popular type of database. It's not a relational database. It's basically a key value pair sort of databases, right? And these are sort of popular in the big data world and e-commerce sectors where there's large amounts of data. NoSQL is very popular, and AWS has an offering for that, right? So it's called DynamoDB. So this is a very scalable NoSQL data store where you can have millions and millions of records and very high performance, right? There's also in-memory type of databases. Some of you may have used Redis, right? This is a in-memory key value pair database, and Amazon's offering for this type of database is called Elasticache. All right, and data warehouse is something that we've already covered. This is Redshift. This is a very large-scale data warehouse offering that is also available. All right. So, now looking at these two slides, right? You have compute, you have storage, and you have databases, right? So you're sort of seeing that the core infrastructure elements for applications are in place, right? Now, if you look at the other two boxes here, there's networking and security and identity, right? So these are sort of allied services, right? If AWS only offered infrastructure without taking care of networking, without taking care of security, right? It would not work, right? You would not be able to do everything that you needed to do. So they offer all kinds of allied services, right? They give you more and more reasons to use AWS. And some of the important things are virtual private cloud. This is a very important concept. You will most likely end up using virtual private clouds simply because Amazon or AWS has made virtual private cloud the default mechanism for your server instances. Right? A few years back, you could set up server instances without a virtual private cloud, right? But now almost all instances have to be created in a VPC, right? And you remember we spoke about public cloud versus private cloud. So this is a third idea, which is, it's something between private and public in the sense that this is within Amazon, right? So it's not on premises, right? But it is ring fenced. The security and networking is done in such a way that your VPC is isolated from the public internet, and you have an option of only having the infrastructure for yourself, not sharing the hardware with anybody else. Right? So it's a VPC, and this is something that you should focus on. But then there are other offerings as well, especially for the enterprise market. There is something for direct connection, where you can connect from your premises, from your data center, to the Amazon infrastructure in a secure fashion, typically using a hardware box on your premises and typically using leased lines, right, so that you don't connect via the public internet. Right? So these things are possible. And then DNS, which is a very basic service, there's an offering called Route 53, which offers domain name service, right? Translates domain names into IP addresses. But it also does other things, like it can detect if your IP translations are working, if your servers are down or not. And based on that, you can take some action as well, right? So it's DNS plus some other capabilities. And finally, load balancing. This we have covered, right? It's part of the networking as well as the compute space. It allows you to sort of distribute your network traffic to multiple servers behind the load balancer. Okay, any questions? Okay, guys, I may be seeing your messages a little late. I think the tool sort of delays this a little bit. So I'm seeing a question here from Bhaskar. And your question is there a messaging system in AWS? Yeah, so the answer is yes. We'll cover that in the next slide. Basically, if you want an email system, right, where you send out messages in bulk, or you may have transaction-related messages, right? So definitely for emails there is one. There is also something called SNS, Simple Notification Service. And this can send notification via email, via SMS. It can send notifications to apps, those in-app sort of notifications. So broadly, yes, the answer is yes. And depending on your need, you'll have to sort of choose what service and what mode you want to use that particular service in. The next question is from Sasanka, and what you're saying is where can we read more about each of these services? Yeah, so this is, let me show you here. There's actually, decent documentation. If you just go to AWS, right? So this is the AWS site, and if you go to the menu here, you can, these products are given here, right? So this products, and these are the categories, right? Or you can just click on the product right here on the top, and there's video material, and these are the various categories, right? So if you want to read about virtual service, there's a lot of information here. Okay, so for example, I've clicked on this EC2 service, right? The virtual server offering, and there's a summary. There's some video material. There are some use cases, right? And on the left side, you can see more details. There are more detailed product information, and there's also, in this case, instances, the types of instances, right? So you can see micro instance to large. Pricing information is also available, right? And then for developers, and then there are FAQs. So a lot of documentation on each product. All right. Okay. Okay. Now let me go to the third box here, right? It says security and identity. Now, because of this public cloud, right, and most customers have had fears, right, that public cloud is not, they are sort of giving their applications and data to a third party, and what are the risks associated with this, and whether this is a good idea or not, right? So right from the start, AWS has had a very strong focus on security. Right, and if you read about the security practices of AWS and the certifications and audits that it sort of undergoes, you'll find that, for example, they are ISO 27000 certified, right? They are SaaS 70 certified. So these are various sort of security-related certifications that data centers can undergo, and AWS has all sorts of certifications, right? So it's a really secure infrastructure, and their security practices, that you can see if you use AWS, you'll find that by default their security practices are very strong. For example, each server has a firewall, right? And by default, that firewall is closed. Another example, if you try to get a server, you can only connect to that server using public and private keys. So you need to sort of download a private key when you're trying to get an EC2 instance, right? So by default, their security posture, the security practices are very, very strong, right? And these services that you see under security and identity are sort of part of that overall sort of posture, security posture. So first of all, what you get is things like identity management and access control, right? And these are, there's a service offering called IAM. Right here in the middle, you can see here, identity and access management, right? So this is something that you should definitely look at mastering, right? Now, once again, you can see a lot of services here, right? And it's highly unlikely that you will use more than 5, 6, or 7 of these, right? Because depending on your focus area, you may not need to use these things, right? But IAM, identity and access management, is something that you'll definitely need to use, because what this does is it controls, it allows you to control who has access to your AWS infrastructure, right? For example, who can install or who can launch new EC2 instances, right? Who can look at billing information, right? Who can create new users, right? So these are the sorts of things that you can do with identity and access management at a very granular level, right? You can control minute things using IAM, and this is something that you should definitely sort of try and master. Okay, so identity and access control is basically the IAM side of things. For enterprises, now these key store and performance and security optimizations may not be important for startups and small companies, but for large enterprises, regulated industry, there are certain new offerings from AWS, right, which are essentially things like Inspector. You can see this is a preview offering. Right, what it does is, if you start this service, it will look at your infrastructure and it will try and point out potential security problems. Right, for example, if you're not using private keys to access your server, right, or if you've not encrypted your hard disk volume, right. So these are sorts of things that it can do. All right. And this is the sort of final slide which covers the services, and you can see there are application services. These are sort of things which help you run your application better, right? And there was a question on can you send messages, right? And you can see right here in the first box there is a service called service for sending out emails, and there's another service for sending out notifications of other kinds, right? Let me show you the dashboard again. So you can see here these are the application services, and there's something called SES, email sending service, right? So you can send bulk emails, and they have mechanisms to sort of track what bounced, and because they put in checks around who's sending emails, right? The chances of your emails bouncing are less, right? Because they take care of ensuring that you're sending it for legitimate purposes and you're sending it from vetted infrastructure, right? Okay, I'm not able to find the other one, SNS here. I'm sure it's hidden somewhere here. So there's something called simple notification service as well, right here. It's over here, right? So this is a push notification service. You can push messages using SMS, or for example, sending it to mobile applications, right? Where within the application there's a notification. But also other things, there are a lot of applications which require queuing. And if you guys are familiar with things such as MQ, message queues, right? These were very popular sort of products from IBM. And queuing is required when there are certain steps in your application flow where you cannot have a waiting period, right? So, for example, if a user is using a website and based on their actions on the website, you need to trigger some actions, further actions, which are jobs on your application side. It is best to queue them up, right, so that the user is not waiting for a response on the website, right? So queuing is a very common sort of architectural element, and it is used for decoupling or loosely coupling your application components, right? It's very important. And it should have characteristics such as it queues it up, and depending on the availability of the other side, right, it sort of safely stores the messages, and once the other side becomes available, it sort of sends the messages. Sometimes it may have to retry sending, right? So all these capabilities have to be managed very well. And there is a service for queuing called SQS, message queue service, right? So similar things. Basically, you may need a lot of services around your application, right, to make your applications work well. And there are sort of offerings from Amazon for that. And again, you can see the pattern here, right? They want to give you more and more reasons to use AWS, and they want to make your job more and more easy. Okay, let's look at the other three boxes here, right? These are the final three boxes. So AWS knows that the business side of companies, right, the management of companies, they have certain concerns, right? For example, on the enterprise side, there is auditing, right? For example, a security audit or an infrastructure audit has to happen. Who used what servers? Who logged in when? Right? What sorts of IP addresses are being used to access our infrastructure? Right? So these are sorts of things which are common on the enterprise side and especially in the regulated industries, right? There is also a concern on the business side on pricing, right? So those sorts of tools where you can sort of assess the usage, how many people are using the infrastructure, how often do they use it, right? What sorts of usages are common? Are EC2 instances used to the extent that that is capacitized for, right? So there are several tools that AWS has come out with, which gives you visibility into your infrastructure, gives you visibility into the usage of that infrastructure, right? Another very good example here is something called Service Catalog, right? This is also a new offering, and I remember from my banking days, right? There was an architecture group within Citibank. I used to work in Citibank, and they had a service catalog, right? Which is basically approved products that we could use. So, for instance, we had a standardization around servers. We could only use HP servers, right? We had a standardization around Oracle as a database service, right? We could only use HP Unix as an operating system. So these are sort of approved list of services, which could be SaaS offerings, PaaS offerings, infrastructure elements, and all kinds of middleware, right? So what AWS has done is it has recognized that there is a need like this in the enterprise market, and they have created a feature where companies can approve AWS offerings that are allowed for consumption, right? So the company can open an account with AWS, and the company's employees can only use certain types of services within the AWS suite, right? So there are sort of management tools like this that are available. AWS also knows that mobile is a big area, like analytics. Mobile is a very big area, and they want to make sure that they are present in this space, and they come out with several new offerings here, right? For example, this should be very interesting if you're in the mobile space. It allows for testing of your mobile application on all kinds of mobile hardware, right? And this is very interesting because for any small developer or any small technology company, it is impossible to create a test lab which has all kinds of hardware and software versions that are out in the market, right? So typically you need to test for Samsung devices or iPhones and Micromax devices. You need to look at the screen resolution. You need to look at the Android version. Right? So there are too many permutations and combinations, and it is normally not possible for small companies, small developers to do proper testing of their mobile applications. But this is an offering which does that for you, right? So they have real hardware sitting out there somewhere, and you have an option to sort of make sure your application is tested in diverse environments. All right. Another interesting thing is mobile analytics, right? Most mobile app developers need to know how their application is being used, right? Where are people clicking? Where are people not clicking? How is the flow of their activities on the mobile app? And these analytics are sort of used to sort of improve the user experience, improve how they can monetize their applications, and so on. Right, so there is a service from Amazon which lets you do that very quickly, right? Okay, so there are several sort of, if you're in the mobile development space, you should sort of look at all these offerings from AWS. And finally, AWS knows that developers are important stakeholders, right? So just like management is an important stakeholder, developers are an important stakeholder for AWS, and they've now come out with these three offerings, right? One is source code management. This is like basically GitHub, I would say, right? GitHub, or you might be using Bitbucket to sort of store your source code, right? And then there's also code deployment. So if you have an AWS infrastructure, and then you're constantly making changes to your code, right? Your software versions are changing and all the time. But you may have a large number of servers. You may have an auto-scaling group with, say, 50 servers running, right? So how do you deploy the new version to these 50 servers, right? You can do it manually, but it takes a lot of time and it is error-prone. So AWS has tools where you can sort of automate this sort of deployment task, right? And finally, continuous delivery, right? So this is not just code deployment, but also building of the code and then testing, right? And then deployment, and then you may also have reaction from the users. They may have feature suggestions and things like that. So this whole cycle of continuous delivery, and especially if you use things like Chef or Puppet, right? So these are sort of open source tools that people are using in the DevOps space. Right. So in continuous integration, continuous delivery sort of thing, if you guys are interested in or involved in, these are some tools that you can sort of explore. All right. So here it is. Developer tools right on the top. You can see code commit, which is like Git repositories, code deploy, for deployments, and code pipeline is the name of the product for continuous delivery. All right, so this is an overview of the various services. We'll talk more about these services tomorrow. Right. Please let me know if you have any questions on these. Okay, now let's look at the market side a little bit, right? We have just a few more slides to go. Why should you choose AWS, right? From a trend point of view, you might be thinking of whether AWS is the right thing for your company to use. Perhaps you should use Azure instead, right? And also from a career point of view, right? As a developer, from a jobs perspective, from a career perspective, is AWS a right choice, right? So that's the question we're trying to sort of consider here. And you can see this is the 2015 Magic Quadrant from Gartner, and you might know Gartner is a technology research company, and they have this very famous term called Magic Quadrant, right, where they sort of map the competitive landscape. Now you can see here AWS is the clear leader, right, and Gartner says they have both the completeness of vision and the ability to execute, right? And this has been the case. The same sort of picture has been there for the last several years, 2014, 2013, 2012, and most likely in 2016 as well. AWS will be in the front. Okay. Now I also want to tell you guys, I've been watching this space for 5-6 years now, right? And I've sort of I'm a practicing AWS architect and user, and I have seen how the AWS product has evolved, right? So simply the breadth of offerings, the speed at which they are sort of adding offerings, the quality of the product is fantastic, right? And you have to look at Amazon.com. You have to look at the history of Jeff Bezos, right, the leader of Amazon.com. And there, just like Amazon.com, their strategy was to completely dominate the market, right? So Amazon.com completely dominates the online retail market in the US, and they started with a simple offering around books, and then they expanded into almost every retail category, right? Whether it's electronics or clothing or whatever it is, and you can expect that AWS will do the same, right? Their desire will be to completely dominate the market, and they have the money, they have the vision and the ability to execute, and Gartner's quadrant shows that. Okay, so my sense is that AWS will be dominant for many years, right? And it's a good strategy for your company. It's a good strategy from a career point of view as well. Okay, now having said that, if you are using Microsoft products, right? If you've been in the Windows space for a long time, then Microsoft Azure is also very it also seems to be on a good trend, right? So Azure is actually one of the products of Microsoft which is doing well, right? Unlike other offerings from them. So that is something definitely to watch out. And you can see here that it's not too far behind, right, in terms of vision and execution. I would also like to point out that IBM is making good moves on the cloud side, right? So they acquired a company called SoftLayer, and although they are very late, right, but my information from IBM insiders is there's a strong commitment behind the cloud product, and IBM has a very strong sort of relationships with large corporates, right? So especially in the large enterprise segment, you should look at IBM's offering as well. And finally, Google, right? Like we discussed earlier, Google's App Engine strategy did not succeed, right? So Google App Engine was not very popular. But if you've been watching this space, just in the last few days, Google has appointed a new cloud leader, right? So there's a new leadership for the cloud business. And because Google is such a big player, because they have so much of investment capability, you should watch Google's activities as well. All right. The other players here, I don't know. I think these four players, right? AWS, Microsoft, Google, and IBM. I think will sort of are the key players to watch. I really have no information about others. I think VMware is still a big player. Rackspace is still a big player in the traditional sense. It has cloud capabilities, but definitely as a data center, it's a big player, right? So this is the competitive picture. Please let me know if you have any questions. Okay, so I'm looking at some questions here. So Sham, you're asking, are you going to deploy a dummy app as part of the course? Yeah, so the answer is, look, we're going to do a lot of hands-on activity, right? So not this week. Tomorrow also is a little bit of theory, but modules 3 and 4 definitely we're going to use the AWS console and the command line and the Java SDK. Right, and as part of those modules, we'll be doing hands-on activity. So you can certainly, start up a server. We can do things like Beanstalk and CloudFormation to sort of actually create an application and deploy it, right? And there are also assignments where you may have to do some of these activities. So definitely, we'll be doing hands-on work. Bhaskar is saying Oracle is entering into cloud business. And can this be changed? Can this? I guess you're asking whether the Magic Quadrant can include Oracle. To be honest, I'm not aware of Oracle's moves, right? So definitely, I mean, I'm sure in the SaaS world, it can offer a lot of things in the SaaS world. I'm not sure if it's going to move in the infrastructure side. I'm not sure if it can move into the PaaS side, right? It certainly has Oracle is still a dominant product in the enterprise market, right? So it can certainly create some sort of a platform at least. But I'm not sure if it has the expertise or the inclination or the desire for the infrastructure side of things. Right? But having said that, I'm not very familiar with Oracle's business activities. Okay, and Shyam is saying IBM is coming up as a blue mix for cloud. Yes, again, IBM also I'm not very familiar, but I have heard of blue mix, and I think you're right. Okay. Okay, guys. So I hope this discussion was good. Now we come to who is using AWS, and I think this slide again is a little bit dated. Perhaps a few years back there were questions of is there widespread adoption of AWS? Are there any big names using AWS? Right, but now I think that's no longer a question. Very large players, especially I think here you can see Twitter. Right, it's a very large database. There's probably a lot of big data type of activity in Twitter. So they are on AWS. Amazon.com itself is a very good example. Right, this is the world's largest online retailer, millions of customers, millions of orders, billions of dollars being spent on Amazon.com itself. So that's a very good use case. I think Netflix is another big one because it is a video streaming service, and that's a good example of how AWS can be used successfully. NASDAQ is another very good example. It's in the financial services space and also very high volume and high demands of its infrastructure, right? So basically, in terms of proven technology, right, there's no doubt there's very widespread adoption by big names. I think, but having said that, it's we still have to see the traditional regulated industry, big banks, healthcare companies, government bodies, large government bodies. Although AWS also has something called Gov Cloud, right? GOV Cloud. So they've sort of created infrastructure, especially for government entities in the US. So I think there's some activity there. But I think the day we see large financial companies and healthcare companies come on board, then we will know if cloud has truly taken hold or not. Okay, now coming to use cases, I think we've covered this a little bit, right? But let's look at this a little bit again. So first of all, if you're on the enterprise side, right, and you're looking to use cloud, you're looking to experiment with it, perhaps do a little bit of, move a little bit of less important applications onto the cloud, then something like low-cost data backup, right, is a use case that you can target, right? So you have on-premises infrastructure, try and see if you can store your database backups on the cloud, right? Another important thing is disaster recovery. It's very expensive to maintain disaster recovery sites in a different place, in a different data center or a server room. So this is a good use case as a first step onto the cloud, right? SaaS, we know because of its widespread user base, it is best done on the public cloud. Content delivery and media distribution, right? Even if you are in a financial services company or a healthcare company, right? You may have content on your public website. You may want to distribute promotional material, promotional video, for example, right? So those are sort of use cases which you can definitely move to the cloud because the content delivery network is simply better at distributing content to users around the world, right? You cannot do this very well in your own on-premises data centers, right? Other use cases like high-performance computing, where you need, say, 256 GB of RAM, right, or several 64 CPUs. Those kinds of use cases, cloud is very good because you typically need this on a temporary basis and you cannot do this on your own data center, right? Also, things like auto scaling is typically not available in on-premises data centers, right? And load balancing, database replication, these things are difficult to do. Big data, again, we've covered this before. Big data and cloud computing go hand in hand, right? Because it's temporary and you need large amounts of infrastructure. So again, a good case. Very large data warehouses is also a very good case, simply because it's the scale of the warehouses can be so large that it is hard to do it in your own data centers, right? So these are some use cases which you can sort of think about, especially if you're looking to move from enterprise and on-premises data centers, right? But if you're a startup, if you're a consumer company like Redbus, Flipkart, then I think there's no two ways, right? Public cloud, AWS is a perfect fit. Okay, guys, let me, any questions on this? Okay, let me ask you a few questions here, right? Especially if you're on the enterprise side. Can you think of examples in your job, right, or in your company that you can move from your in-premises data centers to the cloud in the next few months? Also, it'll be interesting for me to know what sort of enterprises you guys are in. Are you in regulated industries or not? Okay, so Bhaskar has given an example of content management, right? And I agree. I mean, certainly, especially if the content is not can be public, right? If it's not very, if there are no privacy issues or there are no competitive issues, and if the material can be public, certainly it can go onto the cloud. And even otherwise, even if it is not meant for the public, meant for users within the company, and if it's not very sensitive, it can be a candidate for the cloud. Okay, Sasanka is saying, I think you're saying you're in the consumer electronics enterprise. Sham is in the automobile sector. All right. And I think, in both these cases, right, consumer electronics and automobile, they are not very sensitive industries. They're not very heavily regulated from a data point of view. So I think in your cases, many applications and many sort of data stores are good candidates for the public cloud, right? Okay, and as examples, I think Bhaskar, you're mentioning build and deployment systems can be moved to the cloud. Yes, certainly. I think build and deployment systems, especially if usage is spiky, and also because there's no data issue, right? They are basically infrastructure systems. I think good use cases for public cloud. Sasanka, your example of identity management is I think excellent. Although identities can be a little bit sensitive, and identity management software is not something which has spiky usage, right? I would think that there'll be consistent usage. So if you already have infrastructure in premises, and given that identities are a little sensitive, I'm not sure. I'm not so sure if it's a very good candidate for moving to the public cloud. All right. Okay. Okay, guys. Let me go to the last topic here in today's session. This is from a career perspective or a job perspective, and this is a chart from a site called Indeed.com, and I believe they have a database of a very large database. I think they're approaching billion records or something like that of jobs that have been posted in the market globally, right? And this is a chart for the keyword AWS. All right, it's not for cloud computing or any other related term, but for AWS specifically. And you can see the trend. It's been sort of rising up pretty steadily. The percentage is, I think, about 0.3%. 0.3% is still very, very large, right? Given that the size of the database is very large. Just for comparison, I looked this up a while ago. If you search for data scientist as a job role, data scientist is approaching 0.01 or 0.02, right? So it's 1/10 of the jobs in AWS, right? So I think in terms of both in terms of volume as well as the trend, you can see AWS seems to be on a positive trend, right? And all that we've discussed before, right, the culture of Amazon, the leadership of Bezos, and also the track record. You can see that they've added a lot of services. They're definitely, from a business point of view, revenues, number of customers, it's all very, very looking very, very good for AWS, right? So in my book, it's a very good skill to have, right, from a career perspective as well. Okay. All right, guys. So I think this was the last slide. We have just about 20 more minutes to go, and we have a little bit of few questions here, right, in these slides. Let's sort of go through these just to reinforce what you've heard here today. So the question here is, what are the key features, key attributes, or characteristics of cloud computing? So if you can let me know, we can have a quick discussion around this. So the question is, key features, key attributes, key characteristics of cloud computing. Okay, Sasanka, you're saying elasticity. Yes, definitely. That's a key feature. Okay, so let me show you guys some of the slides that we covered earlier, right? So that we can look at this a little bit. So this is the slide, right? It tells you scalability is, or elasticity is similar. The other thing is on demand, right? So you can get what you need right away, and you can shed it also right away, right? And then the third thing that is, I think, very important is the pay-per-use type of pricing, right? So you can pay for server hours, or you can pay for GP hours, right? And there's no upfront expenditure, so your capital expenditure is converted into a small operational expenditure. Okay, I'm seeing your responses now. So use as you go. Sasanka is saying pay per use from Sham, and Sunil, you mentioned on demand, right? So absolutely right. These are some of the key characteristics. Okay, let's go back to the quiz. So here's the answer, right? They've also mentioned auto scaling. It's probably similar to elasticity, I would say. Okay, and what are the different types of cloud services? If you remember, we spoke about deployment models, and we also spoke about service models. Yeah, so Sasanka is saying public, private, and hybrid, and community, right? So these are sort of deployment models. And Sunil, you're saying the same, and Sham, you're saying the same, right? Let's look here what they say. So this question was really about the service models, I guess, right? So your answers are not wrong, but in terms of the service model, it's infrastructure, platform, and software. Okay, and this is the question that you guys were answering, right? So this is basically the deployment models, and it's public, private, hybrid, and community. All right. So I just have a few more slides, guys, talking about tomorrow's session. Before that, do you have any further questions on what we've covered today? Okay, so let me move on to what we're going to do tomorrow. So this is an assignment for you. You guys can do it before tomorrow's class, right? It will be helpful. So you can create a free AWS account if you already don't have it, right? So it's basically you just have to go to the AWS website and sign up. You'll have to enter information like email address, physical address, and things like that. You'll probably have to enter a credit card, right? But you don't have to worry. You won't be billed for it because there is something called AWS free tier, right? So this is the free tier is basically a promotional offering where you can use certain pieces of infrastructure. For example, a micro EC2 instance you can use for free for 1 year, right? So it's a 1-year offer. So in our assignments and other activities, we'll try to use the services which are within the free tier, right? So although you'll have to enter a credit card, you may not have to spend any money, right? So please do that. Please create an account. Secondly, log into the AWS console. I've shown you the console, my console, right? This is what it looks like. You should see something like this. And also, please go through the description of these managed services, right? You can see here the description. If you click on any of these services, you'll see more information as well. So it'll be helpful if you can sort of just navigate the console and take a look at these services, right, in preparation for tomorrow's class. Also, if you can find time, right, you can read about AWS at this site, awsamazon.com. You can look at solutions, right? So amazon.com/solutions, right? So here in the menu, you can see there's a section on solutions, and this is actually it looks at how AWS can be used for different types of use cases, right? For web apps, mobile services. If you're looking for backup and storage, right, especially for enterprise market, big data, financial services, gaming, digital media, and so on, right? So depending on what you do, what type of industry you are in, I think this will be a very good read for you, right? You can also look at products. We've also already seen this, right? But this is basically the products categorized by compute, storage, networking, and so on. So you can also sort of look at these pages. There's a lot of information here. You can log into the console, right? Once you create the account, you can log into the console and explore it. We've talked about it. And this is very interesting. If you're as developers, right? The white papers have very good technical information. So, for example, there are white papers on information security. There are white papers on high availability, right? So this is actually a very good set of documents which will help you use AWS in a very technical, very sound fashion. Right. So if you find time, you can sort of explore these white papers as well, right? And finally, for each service, right, there are certain use cases. So if you see here, these products or solutions, right? For example, if you go to, say, analytics and go to Redshift, in these documents, you'll find information about use cases. What are people doing? What is the industry doing? How they are using this service in their companies, right? So it'll be good for you to sort of become aware of these things. All right. So if you guys can do this before tomorrow, but definitely over the next week, this will be helpful. And for tomorrow, this is our plan. Right, we're going to look at the AWS offerings that we just covered today, but we're going to look at them in greater detail, right? Especially compute, storage, database, network, application services, and deployment, right? So these are the sort of areas that we're going to focus on tomorrow. All right. I think after every session, you'll be asked for feedback, right? And for us, this is very important. Please let us know what you think about the content. Please let me know what how I can help you better, because we're all spending a lot of time. You're spending money. Your companies are spending money on this, so it is very important for us to know how we are doing. And especially if there are ways in which we can do better, right? So the next set of sessions is better. So please take some time to fill the survey and give us some feedback. All right. So I think that's it for today. We've just finished 10 minutes early, and I think that's fine, right? So please let me know if you guys have any questions before we leave. All right, guys. So if there are no further questions or comments, thanks for your time. Thanks for listening, and hope you have a good night. And I'll see you at 8:30 tomorrow.